Okay, in the last video we have discussed about the detailed working principle and construction of the brittle coating method. Now we'll discuss about the advantages of the brittle coating method and the disadvantages of it. So the first advantage is that it is nearly a whole field stress analysis techniques, as the brittle coating method is one of the stress analysis techniques. So any type of analysis can be carried out by using the brittle coating method. Only difference is that this method is used for the heavy duty applications. This method is not a sensitive method, but any type of stress analysis can be carried out by using this particular brittle coating method. Then second advantage is that this technique can be directly applied to a prototype of actual machine or machine components in operating conditions. So whatever the brittle coating method is there, that brittle coating method is applied to the any type of machine components or actual machine. Suppose if I have to go for the stress analysis of a lathe machine, so if that particular lathe machine is in working condition, directly in working condition I can apply this brittle coating method for the stress analysis of that particular lathe machine. If I will take the drilling machine, milling machine, or any rotating components, stationary components, directly on that particular component, this particular method is applicable. In addition to that, for this particular method need not require to prepare a prototype models. In some of the methods, initially what we have to do, we have to prepare some prototype models and we have to conduct the number of tests on that particular prototype models, and then we have to go for the actual analysis. But in this method need not require to prepare the such types of prototype models. Wherever the machines are working directly on that way, in that particular working condition, I can apply this particular method. Then disadvantages. So the first disadvantage is that the behavior of coating, it strongly depends on the temperature and humidity variation during the testing. As already we have discussed that the number of parameters which are affects on that particular brittle coating method. So out of that, the first parameter is the temperature. If your layer of coating is comes in contact with the temperature, that temperature is affects on the layer of coating. So sometimes if your body is in moving condition, or maybe it is in loading condition, at that time if the same bodies comes in contact with the temperature, that temperature effects will be affects on the result, it will be affects on the crack patterns, and it creates the error during the measurement. In addition to that, whatever the humidity is present in the atmosphere, that humidity is also affects while testing purpose. Therefore the care should be taken while before using that particular brittle coating method. We have to check the atmospheric temperature, we have to check the humidity, and then only we can apply this particular method for the testing purpose. Then second disadvantage is that number of variable affecting the sensitivity of coating. Therefore behavior of coating has to be properly understood. As already we have discussed that this method is less sensitive. Why it is less sensitive? Because the final result is not in the form of quantity. The final result we have to decide based on the quality of the figure. Therefore this method is not a sensitive method. Therefore such types of the methods are applicable in the heavy duty applications where the sensitivity effect is not to be considered. For example, analysis of pressure vessel, for example analysis of turbine blades, analysis of wind turbine blades. In such types of the heavy duty applications, this particular brittle coating method is useful, where the sensitivity factor is not to be considered. And the third advantage is that this method is more qualitative in nature than the quantitative. So already we have discussed about the difference between the qualitative and the quantitative. So this method is more qualitative, means whatever the crack patterns we have discussed in the last slide, that is by observing the nature of the crack patterns, we have to decide that whether stress is low, medium, or high. Therefore according to the quality of figure, we have to make the final conclusion. Therefore this method is more qualitative than the quantitative method. Now we'll discuss about the uh, basic introduction related to the reflection polariscope. So why we have to study that particular reflection polariscope? So whatever the last method we have discussed, that is the brittle coating method. In that brittle coating method, whatever the instrument is used for the analysis, that instrument is called as a reflection polariscope. Whatever the crack patterns we are going to observe, that crack patterns are observed with the help of reflection polariscope. So in the chapter number 1 we have discussed about the polariscopic device. So this particular polariscopic device is used for the concept of the photoelasticity. So whatever the photoelastic models are there, whatever the transparent materials are there, all such types of the models analysis has to be carried out by using the polariscopic device. But whatever the polariscope we have discussed in the chapter number 1, that polariscope is called as a plane polariscope. The basic working principle of the plane polariscope and this particular reflection polariscope is same, because whatever the elements are used in the plane polariscope, same elements are used in the reflection polariscope. But mostly the plane polariscopic device is used for the static components, where the components are stationary, but the reflection polariscopic device is used for both the static and the dynamic application. Means it is applicable for the static components as well as it is applicable for the dynamic components. So initially we'll discuss about the basic construction of the reflection polariscope. If you go through the figure, to the extreme lights left side, one source is there. That source is called as a light source, and that inclined line indicates the single light ray is emitted from the light source. So after the light source, one device is there. That device is called as a polarizer. So the basic working principle of the polarizer I have told in the previous video, that is it converts the ordinary light into the polarizer light. Therefore this it will be acts as a one filtering device, because when the light is enters into the polariscopic device, it should be behaves in the simple harmonic motion. That means the light should be moves in only one direction. Therefore that polarizer is acts as a one filtering device. Then after the polarizer, one more element is there, that is called as a quarter wave plate, or it is also called as a quarter wave plate number 1. So the basic function of the quarter wave plate number 1 is to convert the polarized light into the circular polarized light. Then if the light source coming out from the quarter wave plate 1, it strikes on that particular test specimen, and again it is reflected uh, towards the quarter wave plate number 2 analyzer, and finally it moves towards the image recorder. Now I will explain the detailed construction of the use of that particular reflection polariscope. Now initially to the right side, one testing material is there. So let us suppose analyze that particular testing material. Maybe it is in loading condition and maybe it is in moving condition, and I have to calculate the stresses induced in that particular testing material. Now as I have to apply the coating method to that particular specimen, so initially I have to apply the layer of coating. So towards the left side, what I have to do, I have to apply the layer of coating. That is, I have to apply that brittle lacquer material at one side, which testing I have to done. After that I have to keep that particular test specimen for the curing purpose. Then once that particular layer of coating is properly cured, then maybe that particular component is in loading condition, maybe that component is in moving condition. So due to that loading and moving condition, some stresses are induced in that particular test specimen. Some of the stresses are also developed at the surface of that particular testing specimen. So what I have to do, I have to start that particular light source. Once the light source is started, then the light is emitted from that particular light source. It says to the polarizer, that it is passes through the quarter wave plate number 1. Then this particular light source is coming out from the quarter wave plate 1, and it strikes on the layer of that particular coating. Once it strikes, then again it is reflected from the layer of coating, and it is passes through the compensatory device, then quarter wave plate 2, then it is passes through the analyzer, and finally that light source is enters to the last element, that is image recorder. The image recorder means one observer is present at this particular location, and that observer is going to observe the different types of the crack patterns through that particular image recorder. So what happen if this particular test specimen is in loading condition? So due to that loading condition, the stresses are developed, and that stresses are transferred to the layer of coating. And so due to that stress transformation, the different types of the crack patterns are produced in the layer of coating, and that crack patterns are recorded in that particular image recorder. Or sometimes the observer is also present near to that image recorder. That observer will observe the different types of the crack patterns which are produced in the test specimen. So in the last figure we have discussed about that particular different types of the crack patterns. Once again, that crack patterns are in front of you. Such types of the figures are recorded in that particular image recorder, and from that particular figures we have to decide that whether stress is low, medium or high. So this is the basic construction of that particular reflection polariscope. So this is the actual reflection polariscope. So the previous figure, it represents the construction diagram. It contains all the important elements in this particular figure. This is the actual setup of the reflection polariscope. So to the right side, it consists of a light source, then all the important elements, the light is emitted from that particular right side component, and that lights are insert on that particular test specimen, and this light is reflected from that particular test specimen, and it will be recorded to the left side of that particular circle, and that particular left side element is called as the image recorder. That means observer is present to this left side, and that observer will observe different types of the crack patterns through that particular image uh, recorder. So this is about the basic construction and the working of the reflection polariscope, and how that reflection polariscope device is used in the brittle coating method. Now what is the basic difference between the plain polariscope and the reflection polariscope? As already I have told, the plain polariscopic device is used for only static applications, but that actual reflection polariscopic device is used for both the static applications and the dynamic applications, because whatever the light source is there, that light source is tilt in any direction. Means if I have to go for the stress analysis of the wind turbine blades, so what I have to do, I have to apply the light sources on that particular wind turbine. So by using that particular reflection polariscope, it is very simple to apply the light sources on that particular turbine blades, and the analysis will be carried out. So this is about the chapter number 5, that is elementary treatments, in which we have discussed about the brittle coating method, how that brittle coating method is used for the stress analysis, why it is called as a qualitative method, and in the brittle coating method, how the reflection polariscope is useful for the stress analysis. And also we have discussed about the construction of the reflection polariscope, its working principle, and uh, what are the advantages and what are the applications of the reflection polariscope. So this is about the chapter number 5, that is elementary treatments. Thank you.